Welcome to White's Electronics. Here on the banks of the Santiam River in Sweet Home, Oregon, we have a nice factory location. We have a museum. We have all of our current models on display for people to come from all over the world and see the latest models and have them demonstrated or buy them. Here in the museum, we feature all of our early models, some of the most popular models. Some of these models took 25 pounds in batteries alone, so you can see they were quite a bit heavier. And as you progress on to the late 70s here, you can see they got a lot smaller, they got a lot more efficient on the batteries, and of course they detect deeper. Every part of the country has something interesting to find with metal detectors. Here's a good-sized copper nugget from the Great Lakes region. Of course, there's gold in California and Alaska. We have the Civil War artifacts, which can involve a lot of research and history to determine where they came from, who may have owned them, who may have lost them, and when. Now let's go check out how we build them down in the factory. So this is one of our more volatile processes occurs in this building. We're spraying the conductive spray paint, or the coating. The plastic parts have to be coated with a conductive paint so that they can be shielded against both static and the EMI type interference. This has 6 heaters and 6 air conditioners feeding this small building, and it goes out the stacks every 3 seconds, but it has a 108-degree flash point, so everything has to be under 108 or it could go kaboom. Let's go into the tool and die shop now. Nobody makes tools to make metal detectors with, so we end up making a lot of our own tools. So we have tool and die makers in-house that'll work on those projects. Sometimes they get not so engineering type drawings, and sometimes they get real engineering drawings, but they will figure out how to build the part. A lot of times they'll have the prototype part and they have to develop a tool to make that part with in a production environment. And that requires that they take a lot of the labor out. Labor is expensive, so the more labor it takes to build it, the more expensive it is in the end. So of course tool and die is going to be working to try to take a lot of that labor out of those builds. And they're working with tool steel, with aluminum, plastic, wood, plexiglass, anything you can imagine. Some of these tools can be quite complex. You can see one here getting ready to go back up. Not only do they invent and manufacture the tool, you have to make them 2 at a time. If one fails, you're out of business. You got 2 tools, identical. They'll maintain those tools as they wear, and each time they maintain them, they'll think about, how can we make that tool work more efficiently and be used with less labor. Here in plastics, we're working on anything that is a plastic part. You can see they're getting ready to make the lower shafts here. One thing that we've learned over the years is that the nylon rivet is superior to glue. It's much stronger, provides you a much stronger part. And so we're not gluing, we're using a nylon glue, or nylon rivet, a nylon end piece, and a composite rod. Of course, these are made in a number of different lengths for different models, and they have their engineering specs here to build to. All of the plastic will be recycled, so all the trimmings and all of the extra parts are going to be resold and resold back to us. Here you can see they're working with some of the new MX Sport search coils. Here in vacuum forming, we have a vacuum compressor, which is the opposite of an air compressor, and that's why the tank is so heavy duty. There's no air in the tank, and it's sucking rather than compressing air. We're mounting plastic sheets on the spinner here, and it's spinning through a multi-stage oven. When it comes out of the last oven, it's hot enough to come onto the tool. The vacuum forming tool has a lot of holes in it, that's where the suction sucks in. So as the hot sheet comes out, it goes onto the tool, sucks it right into the right shape. She's going to mount a new sheet, spin through the ovens. Just let that cool a little bit, she'll pop that off. That'll go into the next room to be trimmed up, and we've got us a loop cover. The search coils are, the reason they call them coils is you have coils of wire inside your search coil or loop. You've got a transmitter and you've got a receiver. You induce a current in the transmitter, creates an electromagnetic field. You create a current in the receiver, which also creates an electromagnetic field. You balance those 2 fields to ignore one another. That way, when anything conductive gets into that field, then they crash into one another. By measuring how hard they're crashing into one another, we can tell you if it's probable a nickel or probably a nail. So that's where we're getting our VDI, is from the coil itself. Of course, there's the concentric coils, which are typically your round transmitter and receiver, and then there's your double D coils, which are your D-shaped coils. Here you can see we're lining up coils. As far as you can see, this is what they call the loop room, or the search coil room. So they're just focusing on search coils here. You can see these are completed, ready for another test. These are waiting for a secondary tune. That's why the wire's left out. That's what a coil looks like before it has its filler. Then of course here's the same coil filled, and then we're going to retune it. The epoxy tends to expand and contract, so we'll tune it once, we'll fill it, we'll tune it again, we'll finish filling it, and we'll check it again. Search coil tuning involves matching the frequency to the frequency range the metal detector is going to be driving it at, and nulling it. And nulling it means that the transmitter coil doesn't see the receiver coil or any of the other metal that's used in its construction. So frequency and null, and it's kind of different for each type of coil, but we'll be working with that a lot. Blue light will cure the epoxy very quickly, but it can damage your eyes. And if you're working with it, it's easy to not look at it, but on the other side of the room, you see a flash, you want to look up, and that's why the safety of the curtains there is to protect your eyes. Here you can see a dumbwaiter and a conveyor belt as we're moving our product between floors, making the flow nice and smooth. These are our pick and place machines, or surface mount. You can see some TRXs getting assembled here. These are 1, 2, 3, 4. There's 5 TRX circuit boards. The pick and place machines work with those small components much better than a human could. It'll aim itself. It'll pull parts off the rack. The computer knows where every part goes, and it'll assemble up to 500 parts in a couple of minutes. You can see how small these parts are getting. Each one of these little ticks is a component, and it can be put in the wrong orientation. It has to be in the right spot, the right orientation, and to put 500 of those on pretty quick, and within a couple minutes, it really takes a robot like you see here with the pick and place machines. Here today we're running TRX boards 5 at a time, so you can see they're getting ready to line those up. Basically you flux it, put the parts on, run it through the oven, solders everything, and it's ready for testing and calibration. And you can see she's checking, make sure everything's working like it should. We do our own microprocessor programming here. We write our own software. We'll load that into the microchip here. Still quite a bit of hand assembly. A lot of the larger parts, some of the older designs require still quite a bit of hand assembly. Again, all the aluminum's recycled just like the plastic and the cardboard. The recyclers will be coming and picking up the scraps and melting it down and selling it again. You can see here some of the tool and dies that our tool and die makers have made, and they switch things back and forth on the big presses. One thing we found is that using multiple punches for each stroke saves us some time and some labor. He's doing 2 steps at once here. Here's where we're doing our aluminum welding, or the heliarc welding behind the curtains here, welding the grips on and the tabs for the LCDs. So raw aluminum's coming in, it's getting cut to length, it's getting stamped, it's getting pressed, it's getting bent, and it's getting sent upstairs for paint. This is a phosphatizing machine. This is going to wash with a soap solvent. It's going to actually pit the aluminum so it'll hold the paint very well. It's got an air knife that'll cut that off, get rid of all the water. So these parts are ready for paint. We're using a dry powder paint. It's electrically drawn to the part. As it comes out, it's quite delicate. You could knock that off, but once it goes through this oven, it'll come out with a porcelain-like finish. Chassis has to be complete when it leaves this area, so we're going to silk screen whatever we need to have on the control box. We're going to pop rivet on the battery compartments and the latches. You can see the silk screen there. Instructions on the bottom. Once it's painted and silk screened, it's completed before it leaves this area. The next step is assembly. So the part has to be ready to go. It has to be a completed part ready to bolt together when it leaves here. So they're going to be adding plastic parts, cam locks. They're going to be adding the battery compartments. You can see she's working with the arm cups and the arm cup straps. We're going to be pressing the foam grip onto the rods. Everything to do with the chassis has to be ready to go when it leaves this room. So here we're At the final stages of assembly, all the parts are coming together at this point. Here we can see we're putting together some MX Sports. We test every assembly, and we test every sub-assembly, and we test every final assembly twice. The cages are for the interference. You know, if you turn on a metal detector, it's going to cause this detectors all over this room to start chattering. So these cages ground out that interference. This is a copper screening, a fine mesh, 100% top and bottom, grounded outdoors like a household wiring. And you can turn a metal detector on here and test it with your nickels and your mineral samples and not create interference for the rest of the factory. Here she's putting on the final waterproofing touches to the aluminum chassis. You can see RTV on every hole, rubber speaker, even the speaker bolts are RTV'd up. Here the chassis are getting the circuit boards mounted up. As we go further and further down the bench, we see the wiring harnesses are starting to be installed. Here's circuit boards in these units. Get the top on them, get all the wiring harnesses hooked up, then she's going to test it. And if she likes it, if it tests good for her, it's going to go on to be buttoned up and into the cage for another test to make sure it's working right. Here she's simulating the search coil with a machine. In the cage, it'll be the search coil that's sold with it will be tested with it. If it tests good for her in her test, she's going to use real targets, real mineral samples. If she likes it, she's going to initial it, put it on the rack for packaging. If she doesn't like it, it's going to have to go to a technician to see what's wrong. When they come to packaging then, we package and sell in increments of 4 or 6. So these detectors will be put in package. These tan ones, the African models, actually are sold in increments of 8, so 8 or 16. So they're packaging them up for shipping here. Before we do that, we're lasering on the serial number. And with counterfeiting being a little bit of a concern, we're using a $2 bill for the serial number, matching that to the serial number of the unit. That way to counterfeit this, you have to either counterfeit the $2 bill or buy a lot of $2 bills. It makes it more difficult overseas to counterfeit our product. So here are the conveyor finished products coming up from the factory. Heidi here's packing stuff up to get shipped out, and we ship by primarily UPS for individual, truck for large freight shipments, and we've got all the boxes and packaging to go with it. And so that's all it takes to build metal detectors.